Okay, good morning once again. Today we're going to start our discussion on time series analysis. Last time we discussed the difference between a cross-sectional data with a time series data. A cross-sectional data looks at several individuals at one specific point in time, while a time series data looks at one individual, okay, several points in time, one unit. For a cross-sectional data, you have several units, one point in time. The combination of a panel of a time series data and a cross-sectional data is called a panel data. Okay, I gave you this file, and we're going to take a look at introduction to time series. So I gave here some references. These are very good references. Okay, this one is. Why don't we open this? So this is a very good reference on time series analysis, and what's good with this Penn State University, PSU. All right, you can use this as your reference. Okay, so just briefly, so start 510 nila, and then let's go to time series, lesson 1 basics. Okay, so let's just use this material as an overview of time series analysis. Okay, so here are the objectives, and here are the time domain models. These are models that relate the present value of a series to past values and past prediction terms. So we mentioned this last time, the ARIMA model, autoregressive integrated moving average. So this is the model of choice. Okay. Ordinary regression models that use time indices as X variables. So it is akin to a regression model, but your predictor, your X variable is a time itself. Okay, so there are certain characteristics that we need to consider when we look at time series. We have to look at the time series. Is there a trend? Is there seasonality? Are there outliers in the data? Is there a long run cycle? Does the data give us constant variance? Okay, and are there abrupt changes in your time series? Okay, so this is an example of a plot of a time series. So these are the time series of annual number of earthquakes, seismic magnitude over 7.0 for 99 consecutive years. Okay, so we can see here, if we take a look at the attributes of this time series, there's no consistent trend. There's no consistent upward or downward movement. And there's no seasonality. Okay, we don't see a pattern here that, let's say, every month of June or January, the data is going up or going down. So no persistent seasonality. And there are no obvious outliers. Okay. Now, as to whether the variance is constant or not, it's quite difficult to determine that. We can use a statistical test for that. Okay. So in modeling time series, the method of choice is your ARIMA. Okay, and one of the most simple ARIMA type is AR1, which means autoregressive means you're modeling the time series based on its past values. Okay, so in this portion of our lecture, we're going to learn what an AR process is, what an MA process is, what an ARIMA process is. So if we take a look at this, theoretically, the AR1 model is written in this formula. So you have the time series is equal to a certain constant plus phi sub 1 times x sub t minus 1. So you notice that we're regressing xt, our dependent variable, on its past value, lag1, lag1, which means its past value. Okay, and then plus a certain error term. The assumption here is that your error term, okay, should be normally distributed with mean 0 and constant variance. IID here means independently distributed, okay, with a normal distribution that has a 0 mean and constant variance. Okay, so that in a nutshell describes what an AR1 process is. So this is not an output of R. This is an output of another software, which is Minitab. But you can see here the model. This is the coefficient of the intercept, the constant, and the intercept of your lag1, that phi sub 1. That's the coefficient of the lag1 x sub t minus 1, and it's equal to 0.54, and it's statistically significant.
Hello, sir.
Yes.
I think there's an issue po with the file that you're sharing. I don't think I can see it po.
The file that I'm sharing.
Yes, sir. The
Sandali,
RMD.
Let
Sir,
me.
it's frozen po on our end.
Frozen. Sandali, okay. Let me just stop recording ko muna, pause recording. With you, you have this reference, the one from the Penn State University. Okay, sorry, ang dami nag-chat ng OJT. Okay, where am I? Here. So this one, Penn State University. Okay, there are many references that we can use for time series. And as we said, the model that we're going to use is the ARIMA process, autoregressive integrated moving average. So the concept is quite easy. When you say autoregressive, you are modeling the time series based on its own values. Auto kasi auto self, you're regressing the time series based on its past values. So you have AR1, autoregressive 1, AR2, autoregressive 2. That means that you are regressing, you are modeling the time series based on its past values. AR1 means lag 1. So you're using x sub t minus 1, its past values. So this URL is this one. It's from the Penn State University. Okay, Penn State University has a very good reference for the theoretical constructs of a time series. Okay, so ito yun yung pinapakita ko kanina. I'm sorry, my screen was frozen. So as I was saying, this is a time series plot, example of a time series plot. And when you model time series, you have to consider these things. May trend ba yung data? Is there a trend? Is there a seasonality? Are there outliers? Is there a long run cycle, which is more difficult to show or to identify as compared to short run cycles or seasonalities? This is more difficult to model. And does the data display constant variance over time, or is the variance non-constant? Because if it's non-constant, then there should be a different way in order to model that data. Okay, are there volatilities? Are there abrupt changes? So these attributes we need to understand and know, and this can be observed or this can be analyzed by plotting the data. So if we plot the time series data, we can see if there's a trend, is there seasonality, are there outliers, etc. Now, one of the basic or most powerful methods in modeling your time series is the use of ARIMA. Now, last time I mentioned to you that this was developed by Box and Jenkins. So the Box and Jenkins approach to modeling time series required that the data should be non-stationary. Okay, we mentioned that last time. Non-stationary means, that the data should be stationary. When you say stationary, it means that there's no trend. No trend means the mean is constant. So constant mean, MEAN, and also constant variance. Okay, so constant variance means the volatility or the variance of your data should be constant across time. Okay, there should be no fanning out. Ibig sabihin, the differences between your high values and your low values should not be increasing over time. Okay, nor it should be decreasing over time. So there should not be any fanning out, which means your data is spreading out, and there's no fanning in. The data is becomes smaller across time. Okay, so this is an example of a non-stationary data series. Non-stationary because this has a trend. It has a increasing trend, which means that our time series has a non-constant mean. Hindi constant yung mean. Okay, when we look at this portion, the mean is, on the average, the mean is at this level. Then when we go here, the mean is at this level. So the mean is changing across time. When the mean is changing across time, it means that it has a trend. Therefore, the data is not stationary. Also, maybe we can say that the data is not constant as far as variance is concerned, because there seems to be a fanning out. Okay, palabas yung ano natin, yung difference between. Let me just annotate this. If you take a look at this. Okay, so the data seems to have a fanning out effect. So much so that the variance at this point, ito lang, no? Ito. Pero pagdating dito, the variance is quite larger now. So this indicates that this data has non-constant variance. So if it has non-constant variance, therefore the data is not stationary. Now, it's important for the data to be stationary in order for us to use Box-Jenkins approach of ARIMA. So if we have a data like this, then we have to convert this into a stationary data, stationary time series data, because this is non-stationary. Okay, ito non-stationary to. No? Now, bakit siya non-stationary? Number one, may trend siya. No? Okay, our data set has a trend. It has a trend. So if it has a trend, that means that the mean is not constant over time. Okay, in order for the data to have constant mean, dapat ganito lang siya. No? Okay, so this indicates that the mean is constant. Yan. If the data is behaves this way, then we can say that the mean is constant over time. Okay, and if the mean is constant over time, then that could indicate that the data is stationary. Okay. Also the variance, no? Yung variance natin. Okay, hindi naman nagaganto yung data series natin. It's not increasing over time yung variance niya. Neither is it decreasing over time. So we can say here that the data set is constant in variance, constant in mean, walang trend, constant in variance. Okay, the data set follow a constant fluctuation. No? So we say that our data is stationary because it's constant in mean and constant in variance. If the data is is otherwise, then we say that the data is non-stationary. So what's the implication if the data is non-stationary? We cannot use ARIMA here. Okay, we have to convert this first into a stationary time series before we can use the ARIMA model. All right, clear with those, class? Clear? Is the concept of constant variance and constant mean and constant variance clear? Hello, class? Okay. All right, good. Okay, so let me go down once again. Here, let's just take a look at an example here, yung AR1 model. Ang AR1 model kasi, you model your time series based on a certain constant. This is your delta. This is actually your intercept. Plus, okay, this is the coefficient of your log1 value. Okay, ano yung log1? LAG1. Log1 means, ano ibig sabihin ng log1? Ito yung x sub t natin. Okay, and then we're going to model our data set based on past values of itself. So, for example, sulat lang ako dito ng example. No? Okay, so you have this data. Okay. Let's say, ito yung latest. No? So, 10, 11, 9, 10, 11, 9. Okay. Suppose this is our data. And this is the latest. Sabihin natin ano to? March 30, 2023. Ito, March 19. March 29. So this is March 30. This is March 29. So this data is arranged from the latest to the earliest. Okay, so how do we now model yung AR1 process? So we would like to model this time series. This is our x sub t. So this is our x sub t. Okay, what is x sub t minus 1? X sub t minus 1 will therefore be, okay, for the latest, ang x sub t minus 1 niya will be ito, yung log 1. So that will be 11. And then 9, and then 10, 11, 9. Okay? So ito class yung ano, yung, sorry. Yeah. 11, yung log 1, 9, dapat ito, sorry dapat should be kahanin ito, 9, and then this one should be 10. 10 should be 11, etc. No? Okay, so this is log 1. Now, how about log 2? If it's log 2, for example, it's AR2, log 2, no? AR2, ibig sabihin nun, class, we take on the time t minus 2 value. So we're now going to regress our original data on this time series. 9, 10, 11, and then 19, etc. Okay? Ito na yung log 2. So we're now using a different data set. Okay, let me pause for a while. Any questions about that, class? Clear ba yun so far? Kindly chat, please, if there are any questions. Okay, thank you. How about the rest? Okay. So naiintindihan natin class yung yung log 1, yung AR1 process. Auto-regressive at log 1, which means we are modeling our time series based on the past one period value. Okay, so ang i-regress natin ngayon, yung time series natin on simula, depende kung anong frequency, kung daily data yan, yung value kahapon, yun ang kahanay ng value ngayon, no? Okay? So that's how you will model this one. Yung x sub t natin is equal to phi sub 1 times x sub t minus 1. So you notice there is a corresponding variable there. All right? So I leave you guys to read this other portion here. May residual analysis siya. And then you have an example here of a time series with seasonality. So may seasonality to. Okay, and there are discussions here on the model itself. Okay, so let's now go back to our model. Okay, the packages that we're going to use are, okay. Okay, so I gave you a file that has, some have answers, some do not have. Okay, this one I shared with you. The packages that we're going to use are forecast, FPP3, quant mode, T series, time series. So this has capabilities. These packages have capabilities as far as time series is concerned. Okay, I'll give you time first to install these packages. You may use the pacman, pacpload. Okay, and once you're done, kindly please chat if you have installed these packages. If there's a package that you can't install, please chat. Okay, pakichat ha. Let me just get water. Okay, done na ba? Okay, I know you have to have more time for this. Sige, I'll give you more time to load the packages kasi gagamitin natin to. No? So might as well load everything now. Just tell me if you're having problems also with TSM. So there's a problem with loading TSM, the TSM package. Okay, so I'm not sure if I shared this with you, but if you're having problems with a particular package, of course you can Google it. You can find out how do we install those packages. But let me just share with you in the interest of time. So you have to first install remotes package, and then we're going to use the remotes package. Use the function install GitHub and and write this Kevin Kodzi TSM. He's the writer, and we can download the package and use it in R. So kindly run this, okay, and then please tell me if kindly paki-library si TSM after you run that code chunk. So this is exporting your okay. All right, and then please chat, please, if you were able to load. I forgot to put a line here. If you're able to load TSM, kindly chat, please. Okay, good. Thank you. All right. Okay, so that's good. We have now TSM package, which we're going to use, especially when we're assessing our model. Okay, so these are just some notes that I'm sharing with you. Okay, so what's the objective of a time series analysis? Of course, when we're modeling, we'd like to extract meaningful insights from our data. Okay, and we'd like to develop a model where we can, if necessary, predict future values of our data. So we're using the Box-Jenkins approach, the ARIMA method. Okay, so we know that the ARIMA stands for autoregressive integrated moving average, where AR, autoregressive, makes use of the past values of itself to model the time series. Okay, am I recording? Okay. And MA uses past error terms. And then integrated means you have to do something with the data, transform the data first in order to convert it to a stationary data series. Remember that we cannot use Box-Jenkins approach or the ARIMA approach if our data is non-stationary. Okay, we have to convert it into a stationary data series, and usually you can just difference your data. When you're differentiating your data, you're subtracting the value at time t minus 1 to the value of time t. So when you get the difference, okay, if, for example, there are 10 observations, you will now get 9 observations only because you're subtracting, okay? You're subtracting each consecutive value. So there will be one less value. And usually differentiating the data set will remedy already the situation of non-stationary. Sometimes this might not happen. Okay, so you might need another transformation. You might need to difference again. So that's double differentiating. Or you might just get the log of the data series. So you're transforming the data series. Okay. Why do you need to transform the data series, please? May I have a show of hands? Why? So why do we need to get the difference or get the log? Mark? Sir Mariano? Would you know? Why do we need to adjust the data? And that stands for the either integrated, which means that we have to differentiate data. Why do we need to differentiate? Please. Mark? Sir Mariano, are you here? Do I mean?
Just thinking about the answer.
Yeah. Okay. Okay. Sige, Mark, I'll give you time, no? How about the others? Who would like to venture an answer? Bakit natin kailangan i-difference yung data? Why do we need to difference the data? Let's go back to the past few lines, class. The answer is there.
So,
Yes.
kasi kailangan din kung ano yung past values.
Kailangan
Kung ano yung past values.
kailangan kunin yung past values. Okay? Not necessary naman. Pwede naman hindi natin gamitin yung past values. Okay, let me clarify my question. It says here that you need to difference the data. You need to get the, let's say, first differencing. So your first differencing means you're subtracting the value now with the value yesterday. Okay. Second differencing means, get the difference and then get the difference again. So that's the second differencing. Okay. Why do we need to difference the data? Okay, the answer is, andyan na may answer. Oh. Anyone? In order to, class? Andyan, it's in the same line.
Para makuha sa stationary.
Medyo choppy, ah. Sorry, medyo hindi clear yung voice. In order to, who's that? Kindly, it's to determine, okay, Mark, if there is a trend that can be observed in the data. Okay. So, ano kung may trend? Class. So what if there's a trend?
Sir, because we can't use non-stationary data po, so we have to convert it to stationary data.
Okay. We can't use non-stationary data for what? For?
For ARIMA.
Okay, correct. If you're going to use ARIMA, which is one of the most powerful methods in time series analysis, ARIMA developed by the Box and Jenkins, no? Or AKA Box-Jenkins approach, your data has to be stationary. Okay, kung may trend yung data, that means it's non-constant mean. The mean is not constant. The mean is increasing or decreasing over time kung may trend siya. So you cannot use ARIMA to model that. So how do we address that? We have to convert the data first into a stationary data series so that we can perform an ARIMA process. Okay? That clear, class? Pause muna ako. Paki-chat nga kung clear yung concept na yun kasi importante yun eh. Dapat we should be able to understand that we cannot use the Box-Jenkins approach or we cannot use ARIMA if the data is not that stationary, is non-stationary. Clear ba yon, class? Okay, kailangan class clear sa atin yan, ha? Okay, good. Thank you so much. All right, so now, as we said, assuming that the data is already stationary, then we can now perform an ARIMA process to determine whether our data follows an AR1 process, AR2 process, or AR sub P process, or MA1, MAQ, or ARMA 11. So these are the different examples of an ARIMA or an ARMA process. Okay. Now, when do we use integrated na to, yung ARIMA? We use integrated if we did some transformation with the data. If initially the data is not stationary, and then we need to, of course, convert it into stationary, okay, like difference the data. Okay, then that construe an integration. So that's why our model becomes ARIMA, autoregressive integrated moving average. So what's an AR1 process? An AR1 process, okay, it's a process where the time series is modeled against its autoregressive, no, past values. AR1 here means the lag one. Okay, so that's y sub t minus 1 plus a certain error term. Okay, so we have here the intercept a sub o plus a sub 1 times the lag 1 value and then plus an error term. Now, ganun din si AR2. You have the intercept plus A1 times y sub t minus 1 plus A2 times y sub t minus 2 plus a certain error term. Okay? Any questions, class? Clear ba yung AR1, AR2? And while we're here, sabihin natin ARP. So yung ARP generic, okay, autoregressive at lag P, which means so, A sub 1, A sub 2, A sub 3. Okay, so this is A sub P minus 1 times y sub t minus p plus A sub p times y sub p. So this is the last coefficient. Okay, A sub p times the log P, the log P AR process plus a certain error term. Okay, once again, let me pause for a while and let that concept percolate first sa mind nyo. Tapos pakichat na lang so far kung clear yung concept ng AR1, AR2 process. Okay, and then kindly chat please if you're okay. If clear siya. Okay. All right, thank you. Now, how about the MA1 process? MA. Si MA, class moving average, you're modeling your data based on its past error terms. So an MA1 process will be your time series y sub t is equal to a certain error term plus your B1, your slope for B1 times epsilon sub t minus 1. So this is log 1 as epsilon sub t minus 1, log 1 of your error terms. It's not the log 1 of your time series itself. So that's an MA process. Now, when we combine this, ARMA 1-1. So ang ARMA 1-1 is a combination of your log 1 of your previous value, autoregressive siya, plus log 1 of your error term. Yeah. Okay, so you have here a certain constant plus log 1 ni time series natin. This is your AR component plus an error term plus the log 1 of your epsilon sub 1. Okay, so ganun din sa ARMA PQ. Si ARMA PQ naman will have yung sa ARMA P dito, no? Okay, log P and Q will be for the MA process. So this P and Q are the, let's say, default parameters for the log of the AR component and the log of the MA component, yung P at saka Q. And on the other hand, ARIMA PDQ, okay, ARIMA PDQ stands for yung P and Q, andyan na si AR component, yung Q is the MA component, and the D is your, ibig sabihin yan, dinifference natin yung, ano to, yung ito yung integration, no? If that is 1, ibig sabihin nun, we are using now a different data set. Hindi na yung original na data set. Ang ginagamit natin ngayon yung difference na data set. Okay? So that's very important to understand, no? Pag ARIMA 111, it means that you're using the difference data set. Hindi natin min-model yung original na data set, but rather the log 1 difference sa data set, and then min-model natin yung past values of itself, yung AR component. Kung ARIMA 111 siya, no? If it's an ARIMA 111 process, so dinifference natin ng isa, log 1, tapos yung P, ano yung P? So this is the coefficient for the log 1 ng value niya mismo. Ito naman yung log 1 ng residual. Okay? So here are the steps in order to do an ARIMA in time series. Unang-una, plot natin, no? Check kung stationary. Okay, if there's a trend, differencing the data can remove the trend. Okay? Kunyari, pataas o pababa yung data. By differencing the data, you can make the data stationary. So if you differentiate class, take note, you will now model a different data time series. Hindi na yung original na time series, but rather the difference data. Okay, that's okay because when you forecast, you can easily go back to the original data. Okay, now let's say uh, hindi pa siya ano, no? Let's say naman yung data natin, non-constant yung variance. Okay, what do we mean by non-constant yung variance? Di ba? We already mentioned that before. Pag yung data natin, not constant yung variance. Okay. Saan na yan ako? Alright. Where was I? Dun sa... So what was I discussing? Ano na ba? Yung ano, yung non-constant yung variance. No? So ganito yung data set natin. May behavior na ganyan. Okay? So this is non-constant yung variance. May fanning out. Fan out. There's a fanning out of your data. Or it can be, pag ganyan, fanning in. So yung value natin, yung variance natin, becomes smaller over time. Okay. So let me just clear all drawings. Okay. Okay, sometimes kailangan natin i-log muna. How will you address nga pala? Sorry, hindi ko pa na-discuss to. How will you address the non-constancy invariance? You get the log. No? You get the log. When you get the log of the data, you will normally you will be able to quote unquote cure the non-constancy invariance. Okay. Now, what about if the data is both hindi may trend siya tapos may stationary siya. Non-constant yung variance. So ibig sabihin yan, again, let me plot that. What does it mean? So number one, yung data natin may trend. So it's going up. The value is going up. So it has a trend. And then also, yan, ito yung mean niya, no? Yung mean is not constant over time. No? It has a trend, sorry. Ito yung trend. Yung mean niya at over time, hindi siya pare-pareho. No? Kasi nag-i-increase nga yung, nag-i-increase yung range niya ng data. Okay, secondly, to take a look at our data, may fanning out, no? Non-constant mean non-constant variance. All right, in that case, sometimes you might need to do this. So question, ano mauuna? Yung paglolog o yung pagdi-difference? Anyone, please? What process will you do first? Getting the difference or getting the log? Anyone, please? Any volunteer, please? What will you perform first? Yung pagdi-difference, tapos saka kukunin log, or get the log first and then get the difference? Okay, you do this if there's a trend and there's a non-constancy invariance. Pag ganun, you might need to do both. Okay, any answers, class? The answer is, guess lang, sino?
Log
Any
po.
guess? Log, bakit log muna?
Kasi po parang, kasi after period, tsaka i-request yung mga ganyan. Yung log na lang.
Sorry? Bell, medyo,
Ay,
nasa
eh,
labas
hello?
ka ba? O medyo yung
Nasa
chop, no?
Nasa school po. Type ko na lang po.
Sige. Okay, how about the others? So what should be done first? Difference muna o log? The answer is, class, the answer is get the log first. Now, bakit kailangan log muna? Bakit ilolog muna siya bago ka magdi-difference? Kasi class, okay, what will happen if you get the difference? Mag-differencing ka muna. Ano mangyayari? Pag nag-difference ka muna, what will happen? To determine if the value is positive or not? Hindi naman to determine, Mark, but thank you for your answer. It's not really determining, no? Ang question natin, which should you do first? Get the difference and then get the log, or get the log and then get the difference? Okay? So, ang sabi natin, you get the log first. Bakit? What if we get the difference first? What will happen? Okay, if you get the difference first, kunyari, ang values natin 10, 11, 9, 12. Kunyari, ganito yung ano natin, 13. Kunyari, this is the latest value. Kunyari, kahapon lang to. Tapos ito, the other day. So what you do first is to get the log. Okay, class? Ano? Hello? What will happen, class, if you get the difference? Sige. Let's get the difference. So ito yung latest, ano? So 10 minus 11, that will be hello, class. Difference yun lang. 10 minus 11, di ba? Negative 1, di ba? Tapos, 11 minus 7, 4. Some values from, yes, correct. Yan. Thank you, Bell. Yeah, that's the answer, no? Magkakaroon tayo ng negative values. Pag kinuha mo natin difference, magkakaroon tayo ng negative values and you cannot anymore get the log of that. Okay, kasi non-existent yung log ng negative number. So that's why, first get the log. So log 10, log 11, log 9, log 11, 12, etc. After getting the log of each, then that's the time you get the difference. Okay, and when you do that, class, na mararemedy na yung yung non-stationary, pagiging non-stationary ng data natin. All right? So it's important that you have to convert your data first into a stationary data set before you can perform yung yung ARIMA model. All right? Now, there are some statistical tests. So after the transformation, you can check using the ADF test, augmented Dickey-Fuller test yan, KPSS test, etc. Okay, so makikita natin kung talagang stationary na yung data natin using the statistical test. All right, then after that, ipa-plot natin yung ACF at saka PACF. Okay? So what happens here? Plot the ACF and the PACF. Now this is used for determining whether our series has is AR or MA or combination. Okay, so yung concept ng ACF at saka PACF is very important in time series analysis. Autocorrelation function and then partial autocorrelation function. Okay, plotting the ACF and PACF will allow us to determine AR process to, or MA process to, or ARMA process to. Okay? Now, after we have done that, after we have plotted the ACF and PACF and determined what's the best model for this, yan, trial and error na yan, ano? Is that an AR1 process? Then try natin AR1. Is that an AR2 process? Try natin AR2. Is it an MA process? Try natin MA1. Try natin ARMA process, etc. Okay? So ito, class, ito yung ginagawa namin dati, no, nung minamanual pa namin to. Pero ngayon, class, ang dali na nito sa R, no? No sweat na to. Itong portion na to. That's why itong part na to, identification of the best fit model, given the values of the model na generate ni R, hanapin natin pinaka-best model. Actually, identify din niya kung ano yung best model. Okay? And then after choosing the best model, then we can now do a forecast. Okay? After we have the model, pwede natin i-forecast. Okay, let me close this. All right, is that clear, class? Clear ba yung how to address yung non-stationarity? Kung may trend, difference lang. Okay, kung may non-constant variance, get the log. Kung pareho, then you first get the log. Tapos i-check mo ulit kung by getting the log na-address na yung trend at saka na-address na yung non-constant variance. Because sometimes ma-address yun eh, pero sometimes hindi. So kung hindi pa na-address lang yung non-constant variance, kunin naman ngayon yung difference ng log data. Okay, that's why your data set now will be different na, hindi na yung original data na inaaral natin. Magiging different, D-log na siya, difference ng log ng data natin. All right, then you can forecast also. Forecast. After identifying your final model, you can check again yung residuals natin via the ACF and PACF. Okay, gawin ko lang yung drawings. Okay, any questions so far? Okay, before I forget, class, definitely hindi natin matatapos to, no? Pero in the interest of time, ipopost ko na rin yung GARCH lesson at saka yung panel data series, no? I'm going to post videos and the file for that. Again, in the interest of time. So, next meeting, di ba, ano tayo face-to-face? We hope to finish with this, no? And then, nakapost na rin dun yung GARCH method. Okay, naka-explain naman dun sa video na yun kung what's the GARCH method is, and also the panel data analysis. Okay, so let's now load itong data. I'm sure I didn't give this to you. So data natin, air passengers, and then i-view natin siya. And then let's give it another name para mas maiksi lang. AP, and then i-view natin si AP. All right, so kindly run this. Okay, so the airline air passengers data set is from the datasets package. Okay, so let's run this. Run ko itong dalawang to. Okay, so ito yung airline ito yung airline, no? So it's only a vector consisting of, konti lang pala, 144 datasets, no? Okay, where was I? Okay, then let's rename our air passengers. Mahaba kasi. Just use AP, air passengers. Okay, so na-identify na ano natin tong AP. And then if you view AP, yan na naman siya, no? Okay, let's just take a look at the yung head ni AP. First 10. So ito yung mga values niya. Gawin natin first 24 na lang. Alright, so the data set is meron tayong years component at saka yung month, no? So apparently monthly data siya. Yung airline passengers data. All right, so let's I didn't give you the code class because you were supposed to write it. So kunin natin yung structure ng AP. Okay. Let's take a look at the structure. Our data AP, it's a time series from 144 observations from 1949 up to I think this should be 1960. Kasi 12 years, so 1949 dapat up to 1960, no? Kunin natin yung tail ng AP. Tail. AP last 24. Oh. Tama. Hanggang 1960 lang class, no? 1960. Okay, December. All right, are there any questions? Face-to-face, hindi, di ba napag-usapan na natin yan? Pero yung iba kasi, may query dito, si Bell, kung face-to-face, next. Pero I don't want to risk Bell kasi towards the end na tayo, baka na naman hindi gumana. So, might as well just do online first. And also the others are, some of you already informed me that you'll be going to the provinces or ngayong Holy Week na to. So, pero attend kayo class ng ng session natin, wherever you are. Okay. So, tayo online tayo next Monday. Okay, so i-plot lang natin yung data natin. Okay, for this one, i-share ko na nga ito kasi para mas mabilis tayo, no? So let me just chat this. Okay, kindly copy this. So we're creating this object called P1 and it's a plot. Plot siya na AP. All right, I hope you have created AP, no? Which is just for air passengers. Binago lang natin pangalan. And X label niya date. Y label is passenger numbers in thousands. And then yung main label natin is air passenger numbers from 1949 to 1960. Okay, so let's run this and see how our data looks like. Okay, so this is the plot of our data. There. Tabunan siya. Okay, why is it taking long to load? Alright, dito na lang. Sige, ayaw niya mag-load. Okay. Now, question number 1, is our data stationary? Is our data stationary, yes or no? I hope I get a quick answer. Okay, thank you so much. No, definitely no siya. No? Bakit? Oh, number 1, may trend, di ba? The data is going up. May upward trend siya. Pangalawa, non-constant variance. No? Ano? Right? There's a fanning out. So in both instances, hindi stationary data natin. Not constant yung mean, non-constant variance. Okay? And nowadays class, kahit na ganyan yung data natin, pwede nating gamitin yung isang function called auto.arima. Tapos si R na yung magko-convert sa atin into a stationary data series. So, ang dali-dali na nga ngayon eh. Kaya sinasabi ko nga sa inyo last na yung time series data analysis, it's really very easy now. Kasi the advent of packages in R really simplifies everything. Parang di kahon na, no? Mag-auto.arima ka lang, siya na bahala, hahanapin na niya. Kung i-difference ba yan, i-log ba yan, okay, anong data ang finally gagamitin para maging para maging stationary, and then ano yung model na yon. Okay? So very very easy now, no? So parang nagiging na nga parang nothing much for us to do, just analyze yung results, no? All right. So, I think I should also share this with you. Okay, Control C. In the interest of time, kasi magta-time na eh. All right. And once again, class, kindly just copy this. All right, so what are we doing here? Okay, we're using this auto plot. Kasi kanina plot lang, ano? So this is another way to plot our data using the auto plot function. This is from GG45. Lagyan natin dito. GG45. Namespace auto. Auto. Ayaw lumabas. GG45. Okay. Dapat lalabas siya. GG45. Yan. Wait. Saan function? Wait sorry baka nagkamali ako ng ano. Let me just auto plot. Yan. Anong package to? Autoplot is from anong package autoplot? Help on topic was found in the following. So meron kay ggplot2, meron kay forecast. Okay, sorry. I made a mistake. Hindi siya kay GG45, ano? It's from ggplot2. Paki-correct na lang, class. Okay, this is from ggplot. Okay, GG. Okay, dali Ano yung ano? Ano yung function natin kanina? Autoplot. So autoplot the object AP. All right, then label natin X is equal to date, Y is equal to passengers, thousands, and then title A passengers, and then print. So this will give us the same plot, the autoplot function there. Okay, exactly the same as our first plot. You have a trend, you have a non-constant variance, non-constant mean. This is non-stationary. Hindi pa pwedeng gamitin si Box Jenkins. Kailangan kailangan siyang i-convert, i-transform muna. Okay, here again, so let me share again with you. I wanted you to be the one to type this for practice, pero kasi kulang tayo sa time. So ito naman, box plot to, no? From ggplot2. Okay, so this is the code. We're creating this object called BP1 box plot 1. So this is a very instructive box plot. AP, okay, AP on cycle. Okay, ano ba yung cycle ni AP? Tingnan natin Let's get the cycle of AP. All right, and then we can see here that ang cycle ni AP is monthly siya, no? Yan, no? It's monthly data from 1949 to 1960. Okay, so ang sinasabi dito, ito, cycle AP, ibig sabihin, ang i-box plot niya per month, no? So lahat ng January, lahat ng February, etc. Okay, again, yung title. So let's run this, and you can see now the behavior of the data, box plot niya. Okay. Monthly air passengers box plot from 1949 to 1960. Okay. So ito yung 1949, 1950. 1949 to 1960 on a per month basis. Kasi cycle natin, kinuha natin cycle eh. So this is, nagkataon kasi kaya medyo confusing, ano? Nagkataon na 12 years then. 12 years from 1949 to 1960. And then also, 12 months tayo, no? So this is the monthly, no? So this is January. January from 1949 to 1960. Ito naman, July. So we notice that, okay, sandali lang class, Let me just close the door. Okay. So we can see here that it's almost time. Tapusin ko na lang to, no? Makikita natin class na si July, no? Siya yung pinaka medyo malaki yung variation, no? You can see here yung mga whiskers natin. Okay? And medyo ang pinakamaliliit na values yung sa November. Okay? All right. So kindly read through this, class. Read through that. And then we will decompose the data. Okay? And then next meeting, ang gagawin natin, we will now already learn how to model the data. No? So paki-research na lang konti about autocorrelation function and partial autocorrelation function. And then we will learn how to model the data already para masabi natin kung anong AR process ba to, o ARMA process, or MA process, etc. So remember, the end goal of our time series analysis is to be able to generate a model. Okay? Using Box-Jenkins approach, yung yung data natin, ano ba yung model natin para ma-predict yung data set natin. Now, next meeting, we're going to model stocks, no? Prices, not stock prices, but rather stock returns. So sa finance kasi yun talagang tinitingnan natin. No? So titingnan natin yung model ng isang returns ng isang stock. So we will learn how to download stock prices from the internet, and then we'll learn how to get the returns and then model it using the auto.arima. All right. Any questions, class? Any questions? Okay, so siguro kasi medyo ano na tayo sa oras, ano? The file that I gave you is not complete and empty yung mga ano yan. I'll just share with you this file kasi ano to, class 800 rows of data to, no? Kompleto na to, no? Kompleto na to. Andi dito na si auto.arima. Okay? All right. So let me just share with you one. Isang okay, ito, no? Hindi, sorry. Ano na to eh? Apple data na to, no? Okay. So sa second part, it's already modeling, yan. Developing an ARIMA model for the price of Apple stocks. Okay, take note that usually what is modeled is the log returns. Okay, so that's starting from row 577. Okay. So asa na si AP natin? Okay, pakita ko lang to, class, no? Okay, so hindi ko lang makita yung auto.arima model just to show you. Okay, saan ka na? Okay, ikaw, ito, class. Ay, hindi pa to. Okay, ito, class, no? Auto.arima. Okay, ito, no? Alright, so nag-simulate tayo dyan. Anyway, ano na lang, no? I think malilito lang kayo kung iano ko, no? Okay, so next meeting, we'll model yung AP, auto.arima siya, tapos i-model natin yung Apple stocks, yung log returns niya. Para financial time series yung gagawin natin. All right? So let me stop recording now.